Hello everybody. Today I would like to talk to you about another publication that I wrote, and this is about the idea, the theory, that everything in the economy actually is energy. So the currency of the economy is not money, it's not dollar or euros, but it is energy. So this is called the energy theory of value, and this is actually based on an earlier idea of the great in economy, namely people like Marx and Ricardo and Smith, that actually basically said the same thing, but they called it the labor theory of value. And then people will think that labor is not the same thing as energy, but don't forget that labor is an archaic word, and nowadays we use for the exact same concept, we use the word energy. And this then gives you something to think about. So I will show this to you in a moment, actually, to prove to you that this is the exact same thing. But I just want to highlight here the paper that we're talking about here, that the idea is that the economy is energy, and the objective of nature in itself is to convert energy, free Gibbs energy into entropy. So the entire system of economy is to produce entropy at the maximum rate. So the moment that you understand that you can start calculating what is going to happen to the economy. And don't calculate it in euros, but calculate it in joules. Now, to give you now the proof that these two concepts are actually the same, remember that this idea of labor or work, as we say it, that comes from a time before the Industrial Revolution came to its full success, namely by the invention of the steam engine by James Watt, and that was accompanied by the theories of thermodynamics, in which we developed ideas like energy. Before, things were called labor and work, and now it's called energy. And then I don't remember which of the three said it. I think it was Smith that said the intrinsic value of a product is the toll in labor that it is used to produce these goods. So the toll in labor, and that is then an archaic term for work. So what I'm claiming here is that energy is actually the exact same as work. And I'm going to show it to you, to prove it to you here in terms of physics. So first, let's see, we put work. I call it W. And that is, as we know from physics, is the force times the distance. So if I apply 1 Newton force and on an object, and it is moved by 1 meter, I have then done an amount of work that is 1 Newton meter. But then, of course, the unit then what we have here is Newton. So I put this in brackets, the units, times meter. And that is, of course, I want to then compare this to the unit of energy. So how do I do this? I have to convert both of them, energy and work, the units, to a common unit, namely in the SI. And in the SI, the Système International de Unité, that one is has only 7 basic units. And that is, we have, let's see if I remember, we have the meter, that is for length. We have kilogram, that is for weight. We have a second for time. We have mole for quantity. We have candela for light intensity. We have Kelvin for thermodynamic temperature, and we have the ampere for current. So these are the 7 units. All other units can always be then explained. This is a K, kilogram. This can then be explained in terms of these 7. So as you can see, Newton here, oh I want blue, Newton here is not part of this scheme. So I have to convert, meter is, but Newton is not. So I have to convert this Newton into these 7 units. So how do I do this? Well, remember the basic law of physics that I'm sure you all had, that force is mass times acceleration. Do you remember this from secondary school? Well, if you know this, if you know then one of these laws, then you can also then know the units. So Newton is kilogram times meter per second squared. And then we can move this into here. We get the total that the unit of work is, now I need a little bit more space probably, I guess, in a moment. The unit of work is the Newton times the meter, so we get at the end the unit is kilogram meter squared per second squared. That is the unit. And that, as you can see, has all these 7 SI units. Let me put this here. This is SI units. Now, what about then about energy? Well, energy I can also convert. What is the unit of energy? Well, we know that the unit of energy is the joule, but joule is also not part of this set of 7 SI units. So I also have to convert them. So how do I do this? Well, once again, I know a famous equation. In this case, I will use the one of Einstein, namely that energy E equals mc squared. And m, the unit of m, so the unit of m, as we know, is kilogram. And the unit of speed of light is meter per second. But that is then squared, of course. And lo and behold, let me put here another color. This one here, the unit of energy is equal to the unit of work. So, do you get it? If these people talk about work, they actually talk about energy. It's just that these people like Smith, Marx, and Ricardo, they didn't know about the concept of energy because that was not invented yet. At that time, they talked about work, or actually, most of them, they talk about, because a lot of them, they were also German, so they call about Arbeit. So probably you know the famous sentence, Arbeit macht frei. So actually it is what we should say is energy liberates. And this is actually exactly the case because the entire economy is based on energy. All our wealth comes from energy. And as long as you start understanding this, then the entire economy system becomes simply a physics exercise. Thank you for your attention.